Welcome everybody to the 2007 Arnold M. Small Safety Lecture. This year is a particularly special one for a couple of reasons. First of all, and it didn't really occur to us until not too long ago, that this is the 20th in the series. So I think it's really a credit to Arnold and all of his colleagues that such a great lecture series has continued on this long. It's also an interesting celebration because it's Ken Laughery's birthday, and how fitting of a time for him to give this lecture. The first speaker will be Kenneth Laughery, who's an emeritus professor of psychology at Rice University. He earned his BS in metallurgical engineering and an MS and PhD in psychology, all from Carnegie Mellon University. He's held faculty positions at the State University of New York at Buffalo from 1963 to 1972, and the University of Houston from 1972 to 1984. He's a fellow and past president of the Human Factors and Ergonomics Society, fellow of the American Psychological Association and the American Psychological Society, and he's a member of the Society for Industrial Organizational Psychologists. His interests and work focus on safety, particularly the topics of risk perception, safety communications, including warnings, and industrial accident analysis. After Ken, Mike Wogalter will take the second half of the talk. Mike is currently professor of psychology at North Carolina State University. He earned a bachelor's in psychology from the University of Virginia, an MA in psychology from the University of South Florida, and a PhD in psychology from Rice University. He has also held faculty positions at the University of Richmond from 1986 to 1989, and Rensselaer Polytechnic Institute from 1989 to 1992, where I first met Mike. He was also a visiting scholar at the Liberty Mutual Research Institute for Safety from 1997 to 1998. Mike is a fellow of both the Human Factors and Ergonomics Society and the International Ergonomics Association as well. Mike has authored or co-authored over 300 publications in the areas of human factors, but primarily in the specific sub-areas of warnings, risk communications, and safety. On a personal note, I'd like to say that I think these guys have both contributed to the society and to human factors generally in a number of ways that go well beyond their published work. Both have applied tenets of human factors in the forensics domain, and they've been a mentor to a lot of us, including me. So, Ken Laughery.
In our presentation here today, Mike and I are going to talk about safety communications, warnings. Our intent, or our goal, is to provide some impressions or perspectives, our impressions and perspectives, about warnings issues represented by the questions in the title of the talk that you see here in the projection. One question is, where are we now? In other words, what have we learned about warnings from research? What's important? What's not important in designing effective warnings? We also want to explore some of the factors that have influenced the directions the research has taken. This is the how did we get here question. One such influence that we find interesting is the work that human factors and ergonomics specialists have done as expert witnesses in product liability and personal injury litigation. It's not our intent to talk about the role of the expert witness, but rather to present a few examples of how issues that emerge from such expert work may have influenced warning research. Incidentally, the Arnold Small Safety Lecture, the context of this presentation is an annual event sponsored by the Safety Technical Group to honor Arnold's contributions to our discipline. As a footnote, Arnold was also one of the central figures in establishing the forensics professional group. So if we talk briefly about some legal cases involving human factors experts, we're not straying from topics that Arnold would have found relevant. The third question in our title is, what should we do next? Advancing technology and expanding global trade are but two of the opportunities and challenges for the warnings research of tomorrow. Growing international trade creates issues of greater target audience diversity, language barriers, illiteracy, and cultural considerations. The ever-accelerating sophistication and availability of technology creates opportunities for applying that technology to warnings. We have some thoughts and ideas to offer about that. In an effort to provide some context for our presentation, I'm going to comment briefly about the points in this slide. Warnings can be viewed as a communication tool for achieving environmental and product safety. The purpose of warnings may be addressed from a few different perspectives. As a communication, a warning is intended to provide information for the target audience to whom it's directed. There's general agreement that warnings should include information about the hazard, the consequences, and instructions regarding safe and unsafe behavior. This information can then be used to make informed decisions regarding compliance. A metric for success, given this purpose, might be whether the warning information was received and understood. Warnings can also be viewed as an effort to influence or control behavior. If a person using a toxic solvent that can cause chemical burns on the skin does not wear the rubber gloves that was called for in the warnings is considered a failure. In short, this purpose of a warning and a measure of their success focuses on whether the behavioral intent of the warning is achieved. And the third one is reminder, and the reminder function of warnings can be thought of in terms of the distinction between knowledge and awareness. A person may have knowledge about a product hazard, its potential consequences, and the appropriate safe behavior for using it, but the important issue is being aware of it at the proper time. The auditory signal and visual symbol in our automobiles that reminds occupants to fasten their seatbelts is an example of a reminder warning we're all familiar with. In the fields of safety engineering, as well as in human factors and ergonomics, there's a concept that's usually referred to as the safety hierarchy or the hazard control hierarchy. And this hierarchy is a set of properties for dealing with hazards that most of us know: the priority scheme, design, guard, and warn. If there's a hazard associated with a product or environment, the first and the preferable approach is to design it out, to get rid of it. Eliminating a pinch point in industrial equipment or substituting a non-toxic chemical for a toxic component in a solvent are examples of alternative design solutions. Of course, it's not always possible, technologically and economically feasible, to eliminate hazards. The second priority is guarding, and it is intended to prevent contact between people and the hazard. And this approach may take the form of physical guards, such as personal protective equipment, highway barricades, and fences around electrical stations or swimming pools. Guards may come in a variety of forms, and here's a couple of examples of physical guards that do. But guarding may also be procedural, such as the physician's prescription needed to purchase medications. But guarding, like alternative designs, is not always a feasible solution, and sometimes they just don't work. The third line of defense against hazards is warnings. And warnings, of course, are intended to provide people with information needed to use a product safely or to function safely in some environment. There are reasons, of course, why warnings are third in the safety hierarchy behind design and guard. People may not see or hear a warning, or they may fail to understand it, or they may simply not be sufficiently motivated to comply with it. Influencing and controlling behavior is often difficult and seldom foolproof. However, such concerns are not a basis for not warning. Rather, warning should be regarded as one tool or approach available to designers and manufacturers for addressing environmental and product safety. While people from various disciplines have contributed to the warnings research activity, a substantial portion of the research that's been carried out has been by human factors and ergonomics specialists. And it's been reported in the human factors literature. It's not surprising, of course, that people in our discipline have played a significant role in such research. After all, warnings are part of the interface between people using and maintaining a product or environment, and such interfaces are the domain of our discipline. Similarly, one can think of warnings as a display, a subject matter of obvious interest to people like us. Two theories or models have characterized many, perhaps most, of the theoretical efforts regarding warnings. Those are communication theory and human information processing theory. It's not my intent to discuss these in any detail here in this presentation, but rather just a very brief overview will indicate how these approaches have been employed for organizing and conceptualizing research on warnings. Typical basic human communication model has four components: the source, the medium, the message, and the receiver. The human information processing framework is a stages model, consisting of stages through which warning information flows. At each stage, the warning is processed, and if successful, flows on to the next stage. Processing failure at any stage can block the flow and result in the warning not being effective. The communication and human information processing models have been combined into a single theoretical framework for warnings, and that's been referred to as CHIP. And the CHIP model is shown in the displayed figure. And similar models have been suggested by others who work in this domain. The feedback loops on the right of the figure indicate that what happens at one stage can influence other stages. For example, if a warning is noticed and encoded, that's the intention stage, but the person did not understand the message, the comprehension box, that person may read it again. Thus, the processing of a warning message may be more complex than the simple single flow of information through a linear sequence of stages. Models such as the CHIP have been useful in organizing the research literature. They've also been useful in diagnosing warning failures. Identifying where in the stages of processing failures occur enables the warning designer to focus on alternative designs that may increase or help the likelihood of success. And the identification of such issues raises questions, and in this regard, the theory has played a significant role in guiding the research of the last 25 years. It's also important to note the concept of a warning system. The notion of warnings being a label, a statement or picture in a manual, a posted sign, an auditory alarm, is much too narrow a view of how such safety information does or should get communicated. There may be many components of a warning system for a given product or environment. The warning system for a product may include a printed statement on a container box, for example, a package insert, a user's manual, and a verbal message at the point of purchase. How such components interact and complement each other is an important consideration in warning design. For example, different components may play different roles in the communication. Some components, such as an auditory alarm, may be intended to capture the attention of the user and at the same time then direct the user to a visual display panel for more specific kinds of information. Also, different components may be intended for different elements of the target audience. Prescription drug warnings, for example, in communications directed to physicians may employ language more technical than the language on the label of the pill container that gets to the consumer. I'm not going to really comment much on research methods. As in most research addressing safety issues, there are methodological challenges to studying warnings. Procedural and ethical constraints must be taken into account. In this slide, we've listed several methodologies or measures that have been employed in warning research. I'm not going to discuss these various methods, as I said, but it's worth noting that warning research can be methodologically challenging, and it requires a variety of approaches. Well, after 25 years, where are we now? In my comments about the purpose of warnings, I noted that the goal of warnings may be perceived or viewed from a few different perspectives. But regardless of which perspective one considers or adopts, there are some things that most people would agree warnings should achieve if they're to have a chance of being effective. First, they must attract attention. That is, they must be noted and encoded. People don't generally go around looking for or seeking out warnings. Thus, warnings must be conspicuous, and they must encourage encoding the content. Second, warnings should lead to appropriate compliance decisions. They should provide the information needed for recipients to make informed decisions regarding compliance. Compliance decisions, incidentally, can be viewed as cost-benefit trade-offs. The costs involved can take the form of effort, time, money, and so on. The benefits of compliance can include avoiding negative health effects, injuries, and property damage. One reason people do not comply with a warning is that the perceived costs of compliance are judged to outweigh the benefits. Thus, a focus in warning design is to provide information such that compliance decisions can be made rationally and wisely. Warning design characteristics, however, are not the only factors that influence attention to warnings and compliance with warnings. Another category of factors or variables that influences attention and compliance includes characteristics of the target audience to whom the warning is directed, as well as situational variables. The user's experience or familiarity with the product or situation, competence or ability to carry out an action, and the perceived costs of complying are factors that play an important role. So what are some of the design factors and target or situational factors that most influence attention? First, with regard to attention, my comments here will address design factors that, and then target audience and situational factors. I'm going to gloss over this topic rather quickly because the warnings research has generally shown that the design factors that matter are generally known or would be the ones that we would have likely predicted before the research was done. They are listed in this slide. The size of the, let's say if it's a print warning, the size of it's going to matter. The color, the signal word, the location, the format, the use of symbols and pictorials are all things that I think we would have predicted that the research has been quite consistent with and shown to be significant in whether or not a warning is going to get noticed. I've got a few examples here of some warnings from actual products. This is not so uncommon as you might think. But I think clearly you would expect that if a user of a product that this came off of that's got warning information embedded in it, it's not likely to capture attention and to be read and processed and so forth. These are the three signal words that are common that most of us are familiar with and the corresponding color that play a significant role in attention demands of warnings. And I just put them up there to remind you. This is an example of poor formatting. Not only is it used minimal what our educational design colleagues would call white space and bullet points and formatting, but it's concentrated in paragraph form, and in fact you can't keep your eyes in one place and see it all. It goes around the corner. So in terms of formatting, it's not a good design. I've picked a couple of pictorials just to show you. Again, these are common ones. This is a hazard pictorial showing an inhalation hazard. I'm talking about attention factors here, and I'm just trying to point out that pictorials obviously play an important role in getting attention to a warning. There's another standard pictorial, consequences pictorial, showing electrocution. You may not be able to read the language. This, again, is a pictorial point. You may not be able to read the language in the warning. I don't know where Mike took this when this came from him. But you might understand it from the pictorial. It says, don't park here. If you do, your vehicle may be booted. Wouldn't be a happy thing. The pictorial of a complex concept about vapors that can migrate to a remote ignition source. Good chance if when you go home and you've got a gas water heater and you look on it, a warning very much like this will be there. It's a standard. This is a montage of warnings from a variety of places in the world that Mike and I put together, but I think you can see that pictorials and warnings are not just common in the United States, but from around the world. Characteristics of the target audience for whom the warning is intended and the situation in which it is presented are also factors in whether or not a warning will be noticed and encoded. Two factors that research has shown to be particularly important are the perceived hazardousness and familiarity. People's perceptions of hazards associated with a product or environment are important determiners of whether or not they will look for and read the warning. Numerous studies have shown that the greater the level of perceived hazard, the more likely people will look for, read, and encode such information. In the context of warnings, familiarity refers to the experience with a specific or a similar product or environment. And many studies have explored the role of familiarity in whether a warning is noticed and encoded. Generally, the results have shown that people who are more familiar with products or environments are less likely to look for and read warnings. So much for factors that seem to be important in determining whether a warning will be noticed and encoded. I'm going to turn now to factors that influence compliance. And as noted, compliance decisions can be viewed as including a cost-benefit trade-off where costs and benefits, as I've said before, may be money, time, effort, benefits, avoiding accidents, and bad things happening to you. Whether or not people using a hazardous product or performing some task in a hazardous environment decide to comply with the warning depends on both the design of the warning system and the characteristics of the people in the situation. Here again, I'll first focus on design factors and then target audience and situational factors. Many aspects of the warning system design can influence compliance. I note three here: the factors that influence noticing and encoding, attention, pictorials, and explicitness. Regarding the first one, obviously factors that influence noticing and encoding, the attention, are important in determining whether or not behavioral compliance occurs. If the warning isn't noticed and encoded, it can't have a direct effect on behavior. Hence, the factors that I mentioned or listed earlier that influence attention are expected to be positively correlated with the likelihood to comply, and the research results generally support this idea. Pictorials, I previously noted that pictorials play a significant role in warnings being noticed and encoded, and a substantial number of studies have also been reported showing the presence of pictorials increases compliance compared to warnings without pictorials. In addition to making it more likely the warning information is received, pictorials provide information regarding the hazard, the consequence, or instruction, thus enabling the recipient to make better informed compliance decisions. Of course, pictorials can also help communicate information in situations where literacy or language barriers exist and text information might not be understood. I want to focus a bit more on this factor. The explicitness of content information has emerged as a very important factor in warnings effectiveness. Explicitness is defined as information that is specific, detailed, clearly stated, and leaving little or nothing implied. For example, suppose a person works in an industrial environment uses a chemical product that emits toxic fumes. Further, suppose the inhalation of the vapors can lead to severe and permanent lung damage, and therefore it's important to wear a respirator, a particular type of respirator, when working with the chemical. This warning contains hazard, consequence, and instruction information, but this warning will be of little use or no use to the person exposed to the hazard. It's a classic example of a non-explicit warning. The hazard statement, hazardous environment, communicates little about what the safety problem is. The consequences statement, potential health effects, only notes a potential problem having to do with health. And the instruction, use appropriate precautions, is essentially useless in telling the user what to do or what not to do. Consider the following alternative warning. Now, these two examples emphasize the importance of providing explicit information that will enable people to make informed judgments and decisions. From a motivational standpoint, it's foreseeable that explicit information influences compliance. More specific information about hazards and consequences enables people to make better informed cost-benefit trade-off decisions regarding compliance. Further, explicit information, especially concerning consequences that are more severe, should lead one to predict better compliance. And the research findings confirm this kind of expectation. More explicit instructions, similarly, enable people to better understand and carry out appropriate actions of common research findings. This is a slide that simply shows two warnings that provide explicit or consequences information about smoking. I'm fond of an anecdote that addresses this question too about explicit information of the consequences. There was a case that was tried in Kentucky, and it concerned warnings issues, and it was appealed. Apparently the plaintiffs, I wasn't involved in it, but apparently the plaintiffs lost the case. And it was appealed to a higher court in the state of Kentucky, and one of the issues had to do with the adequacy of the warnings, and particularly, apparently, the adequacy of whether or not the outcomes, the consequences were addressed in the warning. The higher court gave as an example, it upheld the appeal, and it came down with a decision in favor of the plaintiff on the warnings issue. It reversed the jury decision. But the higher court used an example that I thought was kind of fascinating. Keep off the grass won't do if the grass is infested with poisonous snakes. And if that has implications for the consequence, you better say it. Several target audience and situational factors have also been shown to influence warning compliance. And three factors that play a significant role here are, again, familiarity, one called modeling, as well as cost of compliance. And the effects of familiarity on compliance are somewhat complex. It appears that the effects interact with the nature of the experiences that people have had with a product or environment. Not surprising. Assuming no negative safety experiences, a substantial amount of research generally indicates that greater familiarity leads to lower levels of compliance with warnings. However, some research shows familiarity increases compliance. For example, when people were asked to apply pesticides to plants, familiarity with the product resulted in greater compliance with the warning to use personal protective equipment. An explanation for the mixed effects of familiarity on compliance is that it may be mediated by the perception of hazard. The idea that familiarity breeds contempt may be involved in the sense that greater familiarity leads to lower levels of perceived threat that in turn results in noncompliance. But in terms of the cost-benefit trade-off decision, familiarity results in lower costs associated with noncompliance, where the person has had no negative experiences or has not got a particularly hazardous perception of the product, then it's going to result in less compliance. Regarding modeling, People's behavior is influenced by the social context and behavior of others around them. This effect includes compliance or non-compliance with warnings. And several studies have been reported in the warnings research literature that shows quite robust effects of modeling on compliance with warnings. For example, we find greater compliance with warnings to use protective equipment when others were observed using such equipment. A possible explanation is that the actions or behavior of others is a form of instruction. It provides information regarding the safe mode of behavior. It just may also be a form of social influence in the sense of being motivated to behave as others do. Regarding cost of compliance, there may be various forms of costs associated with compliance with a warning, and I've mentioned them as examples: time, effort, convenience, money, and so on. There's been considerable research on the effects of such costs on warning compliance, and the results have shown consistent and quite robust effects. And as I've already discussed, the decision to comply or not to comply can be viewed as including a cost-benefit analysis in which compliance costs are half of the equation. Thus, it's not surprising that cost of compliance is a very important factor in warning effectiveness. In short, if you're designing a warning system, make it as easy as possible to comply. I don't want to take time to summarize, but this seemed like a good point, or a brief summary being in order. So let me just remind you with this slide of some of the factors that seem to be most significant in influencing whether or not people attend to and process warning information. And this slide is some of the factors that I've indicated are most influential in whether or not people will comply with warnings. So much for this rather brief review and perspective on where we are now. That is, what have we learned from the last 25 years of research on warning design and effectiveness? We thought it might be interesting to point out or to comment on some of the events that have influenced the research. And I refer to the second question in our title, how did we get here? There are many factors that have influenced the direction and emphasis of warnings research in the last quarter century. A few are noted in the slide, including the increased concern for public safety in our country starting in the 1960s, government regulations, and a variety of guidelines and standards. These developments in various ways have led to increased use of warnings that in turn has raised researchable questions. Another influential factor, and one that I will briefly explore, has been the expert witness role that human factors ergonomics specialists have served in product liability and personal injury litigation. Many lawsuits include a claim regarding warnings, and people in our discipline have provided expertise on such issues. Such experiences have influenced the questions and issues addressed in the warnings research activity. One of the bases of lawsuits is the claim of inadequate warnings. It's not my intent to discuss the legal concept, but rather describe a few issues that were present in legal cases that led to research questions. I'll note at the outset one of my personal experiences. My first contact to be an expert witness in a legal case involving human factors and warnings issues came from a plaintiff's attorney in Beaumont, Texas in the fall of 1979. And the case involved a man who worked as a welder for a number of years in the Gulf Coast shipyards. As a result of exposure to the toxic fumes giving off during welding, he suffered severe neurological and respiratory disease. That was the conclusion of medical experts in the case. One of the plaintiff's theories in the case concerned the lack or adequacy of warnings. Given that this case occurred almost 30 years ago, I don't have any information about the facts, the warnings involved in the case, so I can't show you that. But my reason for mentioning it is somewhat different anyway. I mention it because as I attempted to analyze and understand the warnings issues in the case, I made an effort to find relevant scientific literature, publications on warnings, and I found very little. There was, of course, a lot of human factors literature on displays, and a rich psychological literature on perception, including risk perception and attention, some of which could be extrapolated to the warnings issues I was addressing. But overall, what I learned was that very little existed in the way of research on the design and effectiveness of warnings. I will mention two other factors that are part of the context for exploring the influence of litigation in warnings research. First, in the 1970s, the amount of product liability and personal injury litigation that was occurring in the United States was growing. Concurrently, the need for human factors and warnings experts was increasing, and lawyers around the country were discovering that people calling themselves human factors types were a source of such expertise. So more and more of us started being involved as warnings experts, and the need for more research to serve as a basis for analyzing cases and formulating opinions became increasingly apparent. A second factor or event that spurred the research occurred in the early 1990s. It was the Daubert decision of the U.S. Supreme Court, no doubt familiar to a lot of you. Basically what it said was that there had to be a scientific basis for experts' opinions, and it spelled out a few criteria for judges to determine whether such a basis existed. Included in the criteria was whether there was published, peer-reviewed research to support the opinions. So, the early 1980s witnessed an upsurge in warnings research, and that's continued to this day. I'm going to describe two categories of cases on which I've worked as an expert that have led to research on warnings. The issue concerns risk perception, location, and explicitness. As I discussed earlier, whether or not a warning gets noticed, read, and encoded is influenced by where and how it's located. During the past several years, I've worked on several cases involving vehicle accidents in which an occupant of the right front seat was injured or killed while riding with the seat back reclined. Crash research data, as well as analysis by restraint system experts, have established that when the occupant's seat back is reclined beyond a point where the shoulder belt is no longer in contact with the torso, the effectiveness of the restraint system is reduced or negated. Two questions emerge from analyzing such cases. First, are the hazards associated with the reclining seat while the vehicle is moving open and obvious? That is, will the occupant realize the hazard when the seat back is reclined and the shoulder belt's off of the torso? This is a risk perception question. If so, there may not need to be a warning. Two studies explored this issue, one that Danielle Smith and I published and one that Tim Rhodes published. The studies showed photographs of occupants in various reclined positions and asked subjects about the hazards. Both studies showed that when viewing the reclined position, subjects rated the hazard greater the more the seat was reclined. The second question is, do people know about the hazard? Other research, such as that published by Dave Leonard, shows that when simply asked questions about reclining vehicle seats, a significant majority report having done it, and relatively few are aware of the safety hazards. What these studies seem to show is that people do not think about the restraint safety issue when reclining a seat, but will recognize the hazard if it's called to their attention by observing a reclined seat occupant in a research context. Given these results, one might conclude that a warning calling the occupant's attention to the hazard could be effective. The second question from the seat recline cases concerns how to warn about such an issue. The specific question is where to put such a warning. It turns out that many of the vehicle manufacturers do warn about the hazard of reclining a seat back while the vehicle is moving. These warnings in virtually all instances are located in the vehicle owner's manual. Here's an example of an owner's manual warning regarding seat recline. However, several studies have been published showing that only about 5% of vehicle owners report reading their owner's manual cover to cover. Rather, the manual is used as a reference document and accessed when some specific information is needed. Vehicle owners' manuals are designed to be reference documents. Thus, research emanating from the litigation work shows that relying on vehicle owners' manuals about seatback recline hazards are not likely to be effective because of the location. That is, they're in the manual, they're not likely to be seen. In the context of seat recline cases, we developed a warning based on the ANSI Z535 standard that would go in the vehicle. And a study that we did, again, motivated by issues encountered in the litigation context, was published and indicated that the on-vehicle warning, such as this, was more likely to be noticed and complied with than a warning in the owner's manual. So it's another example of research influenced by litigation. Another category of warnings, of warning issues that I personally have encountered frequently in my role as an expert witness, has been referred to as the explicitness issues. I discussed earlier at some length that the explicitness of a hazard, consequence, and instructional information in warnings is one of the most important design variables in warning effectiveness. I'm going to mention two examples quickly of non-explicit information in warnings that I've repeatedly encountered in legal cases and that have been among the motivators to carry out research on the explicit information issue. The first example is maybe hazardous to your health. I can't even guess the number of times I've encountered this statement in warnings. It's a classic example of non-explicit warning information. Not only does it fail to tell us what the consequence is, lung damage, chemical burn on the skin, long-term risk of cancer, or whatever, it also fails to tell us how serious the outcome may be. For example, during the past several years, I've worked on a number of cases involving dietary supplements containing ephedra and sold over the counter. There were several potentially serious side effects associated with these products before the FDA banned the ephedra and take it off the market, including stroke and heart attack. Several of these products, however, did not note the more serious side effects, but did include the statement that may be hazardous to your health. A second example is another statement I've encountered countless times used with adequate ventilation. It appears in the warnings on paint, solvents, and a variety of products that produce vapors, dust, and so on. It's the instruction satisfied by opening a window, using a fan, wearing a dust mask, or using a hood with an enclosed air supply. The point, of course, is the warning doesn't tell you. I could go on, but that's enough of that. Instead, I'll refer you to a paper that John Kreifeld and a colleague named Rao published in the mid-1980s. They looked at instruction statements in terms of fuzzy sets and identified 56 fuzzy words or statements commonly used in product instructions. Here's a sample of them, which I suspect for many of you, some may sound familiar. From these few examples, I think you can see why experiences in the litigation context has provided the motivation to carry out research on the role of explicit information in warnings. I think it's time for Mike. Mike is going to talk to us about where we go from here, challenges and opportunities.
Usually when we think of product warnings and signs, most people think of text and symbols on paper or cardboard or metal and that sort of thing. My section of today's talk is going to concern some future things. A lot of my talk today will be to introduce some ideas of where the future of warnings and technology may take us. The topics I'll be discussing will be organized around the following categories: producing warnings, displaying warnings, and with reference to static versus dynamic warnings, obtaining warnings, which will concern information seeking, sensors with regard to hazard detection, tailoring, and finally implementation. And I'll explain what these topics are as I go through the talk. Producing warnings first. Since computers and the advent of desktop publishing, warning production has been easier to do without using professional services. With general word processing programs, with graphic applications, you can make warnings, and pictorial symbols are available on public domain. And also there's several sign building programs, including free ones on the web. Combined with a color printer, people can make decals, signs, laminate them, and these tools also enable rapid iterative development of prototype warnings for subsequent usability testing. Okay, presenting warnings. As I mentioned earlier, many product warnings and signs are made of paper, metal, plastic, and the static nature of these warnings do not match up well with people's abilities and limitations, particularly to one of the main roles of warnings, to capture attention. People are less attuned to stimuli that do not change. Changing dynamic qualities of stimuli generally increase their noticeability. Some forms of dynamic warnings have been available for decades, such as fire alarms and other kinds of auditory warnings and alerts. As I said earlier, people are built to detect change. When something does not change or is no longer novel, it's less likely to attract attention. The reason is habituation. Exposure to anything over time reduces its salience and is less attention-getting. Dynamic warnings are less likely to induce habituation as rapidly as static warnings. However, even dynamic warnings are not immune to habituation. But habituation is generally slower for dynamic than static warnings. One example is a conventional school zone sign. This one is from Raleigh, North Carolina, where I live. And there's several problems with this sign. One of them is that it gives some times of when the warning, the speed limit is appropriate, but it's way too small, particularly if someone is already traveling rather fast. A better idea is to include a flashing light when students enter and leave school grounds. The next slide, this slide, shows that a plain static sign and one that's flashing. The one on the right is better in terms of noticeability and ultimately the safety of children. Here are some other dynamic warnings. The one on top is a countdown traffic light warning from Brazil, and the other two are pedestrian crosswalk warnings. The one on the right is a countdown warning as well. The next slide has some changeable information signs. They are dynamic in the sense that the message can be changed depending on the circumstances. The amount of information one can give on signs on high-speed roadways is limited, of course. Short viewing times need to be considered. Also, there are resolution issues. Most of the changeable message signs in the United States lack the resolution to put graphics, but you'll see the one on the bottom left has a little bit better resolution, and it does include a simple graphic there. The one on the bottom right was taken at a large convention center in Seoul, South Korea. It has a lot more resolution, also in color. These changeable signs have the potential of giving some simple quantitative and qualitative information that could be changed depending on the circumstances. Here's a wind gust warning for a bridge. It gives quantitative information, 68 miles per hour, and qualitative information, as in the words extremely strong. Along the same lines of thinking is that changeable dynamic signs could display the degree of urgency or the level of hazardousness involved. Judy Edwardy of the UK has argued that warnings should be designed to reflect or mirror the degree of hazard involved. And the warning should look or sound more urgent if the situation is more urgent. And it should connote less urgency if the situation is not so great of a hazard. The message conveyed could be more or less urgent by dynamically changing the color, the signal word, and so forth. So you can go from yellow, orange, and red, or caution warnings of danger may be deadly. Also, as I implied earlier, with the wind gust warning example, is that one could change the wording to change the warning's emphaticness. A couple of my students, Soyeon Kim and Jennifer Calley, and I did a study that will be presented in the forensic professional group tomorrow morning, in which the degree of emphaticness of the instruction statement was changed. And we added certain kinds of words, such as recommended or suggested, to the direction statement. And those terms tended to lower the emphaticness of the directions, and other words such as mandatory, necessary, absolutely necessary increase the emphaticness. The point here is that the wording in a dynamic warning could be changed as a function of the degree of hazard that's present. This slide shows a couple of photos of high-resolution flat panel displays. Flat panel displays are relatively expensive these days, but like most electronics, the price is likely to go down. In the future, it probably will become dirt cheap and could be used in a commonplace manner for warning signs and dynamic warning signs. They could be posted on walls of buildings, and signposts, and so forth. And larger ones could be changeable message signs on highways. This slide shows a recent newspaper article on a very thin, flexible electronic display. You might imagine something like this could be placed virtually anywhere, including dashboards of cars. You wouldn't need zillions of warning labels pasted on the dashboard and elsewhere. You could just have something like this that would display the warning information as it's needed. It could be off when it's not needed. Next slide shows some other examples of the so-called electronic paper that's available now. Auditory displays. Of course, for many years there have been dynamic warnings, but they've mostly involved the auditory modality. And until recently, they've been limited to simple or complex nonverbal warnings. But now there's vocal, speech, voice warnings, and the technology is now miniaturized and very inexpensive. Research has shown that voice warnings are a powerful way of getting compliance, getting people to do something immediately. As a matter of fact, the effects shown in some of the warnings research is that it's much larger than most of the print warning variables. And these are a couple of examples of vocal warning products on the market. They're both smoke detectors. One of them is also a carbon monoxide detector. One allows you to go ahead and record your own message. One study that has shown the large effect of vocal warnings was done by Vince Gonzola in we call it the talking box study. And basically what the subjects did is we handed them a box which contained a disk drive, and their task was to install a disk drive to a computer. And in one condition, there was a vocal warning, so when they opened the box, it said to do certain things during the installation process. In another case, it had a large print warning as soon as it was opened, and then, of course, in another case, there was no warning there. And basically, the results showed that the voice warning, which was really just a Hallmark card that we recorded, and it just gave it the instructions, and people were more likely to comply to that than the large print warning. In addition, research has shown that physical variations of the voice can convey different levels of urgency. Voice that is louder with higher fundamental frequency given at a faster rate produces higher degree of urgency. This relates back to my earlier comments that ideally you would like to have warnings that mirror the actual hazard, as might be done with variations of the voice characteristics, in addition to the meaning of the words themselves. Camcorders and computer software that allow editing of digital video are now readily available. Informative yet relatively inexpensive safety warnings videos can be produced. And the availability, you could just witness how YouTube has come into play in the last couple of years. Instructive safety videos could be included with the product at the time of purchase, in addition to the owner's manual. A lawnmower that I purchased several years ago came with a video, and it gave what the features were, but it also included the safety section. These days, videos would likely be put on a DVD or made available on the web, and I'll say a little bit more about the web in a minute. Automotive navigation screens with flat panels could be used to display warnings or provide warnings. We know from research that many drivers do not read their owner's manual, as Ken had mentioned. Thus, a potential alternative or supplement to an owner's manual is to communicate safety information and warnings through the onboard navigation screen or display. For example, it might show how to correctly use the jack to change a tire. Potential disadvantages are the added cost and potential distraction from the driving task, but some of the onboard navigation systems lock out certain functions while the vehicle is moving, and for things like the jack, the car's not going to be moving anyway. So if it is in the moving mode, only high priority warnings might be given during the time the vehicle is moving, and it might be also another alternative to putting a lot of stickers on the dashboard. And it might be a way to communicate that seat recline warning as well, as Ken had mentioned. I don't need to remind you about the explosion of information access that has occurred in recent years due to the Internet. Internet has provided opportunities for new kinds of warnings. People can get information about products, and they could potentially get replacement owner's manuals if they don't have one. This is a page from the National Mower Company, and it gives PDF files for various models that they have that you can download. Also, there's no sense giving a 1990 manual for a 1990 product in 2007 when the state of the art of warnings has changed since that time, or if new hazards have been discovered since the product has been released. The web provides a way to distribute updated manuals, and that could be relatively easy if you're doing modules of warnings where you could change certain sections across the board. Of course, information technology has moved into the age of wireless, and I have an iPhone, and right now, if I turned it on, I can get access to the web, and I can pull up various information, including potentially warnings. And more information is being put on the web every day. There's a few other issues I'll mention regarding the web that have been done with research. If you're going to put stuff on the web that is dealing with risks, they should be easily findable on manufacturers' websites. And Bill Vigilante, who did his dissertation a few years ago, found that the benefits are easier to find than risks. It's very, very difficult sometimes to find the risks. You have to do all sorts of clicks and scrolling to get to them. Another interesting potential is to maybe use the UPC barcoding or some other barcoding attached to the product and be able to scan it in and go right to the manufacturer's website, the product information associated with it. It would be nice if my iPhone had a scanning ability, and who knows, maybe in the future some of these things might. Detection and sensing systems. Technology will benefit warning effectiveness through detection and sensing. Humans have sensory limitations. We don't have the ability to sense certain hazardous stimuli. We can't detect radiation, carbon monoxide, and so forth. There's Geiger counters and carbon monoxide detectors to do those things. Also, people have, or older adults have, age-related sensory limitations, and detection and sensing systems could be used to augment or compensate for these other human limitations. Warning systems that include sensors can do some or all of the noticing for us. And there's a wide variety of sensors currently available, including ones that detect temperature, moisture, smoke, gas vapors, motion, weight, and so forth. And in the next few slides, I'll show you some of these kinds of sensors that are kind of interesting. This one is a wearable chemical sensor that contains crystals that change color when it comes in contact with target hazard vapors or other things. And it senses the amount of toxins that you would not be able to notice but still could be harmful. And this particular sensor is reusable. The coloration returns to normal when the hazardous chemical is no longer present. This next slide is a sign shown in Raleigh, North Carolina, taken by Chris Mayhorn. You might be able to see hinges on it. The hinges are to allow to be folded down when the weather is unlikely to be sufficiently cold to cause the problem that it's warning about. It sort of acknowledges the potential for habituation, that seeing the sign over and over reduces its subsequent noticeability, which is the reason why you want to fold it down. That could be a problem if you become habituated and then it becomes cold and you're no longer paying attention to it. A better method would be to use a temperature sensor, and one of the display screens that I showed you earlier. In freezing or near freezing conditions, a bridge icing warning would be presented. Otherwise, it would not be. This slide shows a different kind of temperature detector. It's a thaw detector that was included in some frozen fish that I purchased. And the dot turns permanently yellow if in warmer temperatures. And it gives you information that perhaps the fish might have been thawed out during transport and then refrozen. So it gives you that kind of indication. These are some other sensing systems. These were I took at a UPS facility in upstate New York. One is called Tip and Tell. Actually, the first two on the left are the Tip and Tell information. And what happens here is that when the box is turned to the side, some of the black material in the middle picture moves to the middle arrow, and you can tell if it's been tipped. And the one on the right is a shock watch warning. It will change color if it's roughly handled or dropped. A kind of simple sensor that is readily available is motion detectors. And I did a study with Mike Kalsher and another colleague at RPI about 15 years ago that demonstrated that using a detector that sensed when a person entered a controlled risk area, which then elicited the presentation of a warning, this led to higher compliance than a static sign or a static sign that was always on or no sign. This is another example of a road sign that has a dynamic warning. This one works when a bus comes into the area and turns its lights on. It transmits something to the sign. I don't know if you can see it, but up on top it has a little strobe light. And so while the bus is in the area and while the lights are going on or turned on with the bus, it will flash. Information can now be delivered when needed with the advancement of wireless communications. Electronic tags, a kind of electronic form of barcoding, are now being placed on or with consumer products for tracking inventory or trying to prevent shoplifting. These electronic tags could also be used to transmit information to warning displays. Let me give you some current examples that are available. One is the ExxonMobil's Smart Pass, where you can pass a key or a tag near the gas pump and it registers, it identifies you, and goes ahead and charges the gas. Some credit cards and debit cards also have some of this capability where you can just bring it by the detector and it registers who you are and identifies you. And an extension of this technology could be used when a person enters a hazardous area and has one of these electronic tags. It could give a warning if you're not allowed to be in that area, okay, or let you pass if you've got authorization. To present particular warnings in highly specific situations, multiple detectors or combinations of detectors could be employed. Combinations of detectors could recognize particular patterns based on physical characteristics, behavioral movements, and other inputs. Together, they can provide greater accuracy and specificity determining what is being detected. The picture on the right is a combination detector that has both a motion detector, kind of heat detector, combined with a simple kind of camera that registers size. And what it's intended to do is to be more specific on what it's going to alert or warn about, a cat versus a real intruder. Another example of multiple detectors is a study described in the literature in which several vital signs were monitored while people were doing rehabilitation exercise. And so they monitored heart rate, respiration rates, blood pressure, and so forth. And when one of the vital signs exceeded some limit or out of range, then a warning was given to stop or slow down, and this multiple sensor system was successful in preventing people from overdoing their rehab exercises. Also, newer generation airbag systems will have multiple sensors. The simple detection, beyond the simple detection of change of velocity. They would sense the characteristics and the positioning of the occupants in the front passenger seat, for example. The idea is to differentiate the presence of a child or an older adult or a package or someone leaning against the window instead of sitting upright. And so when a collision occurs, the system would determine whether to deploy an airbag, and if so, what kind of deployment to give. Tailoring. Warnings could be matched or tailored for certain individuals and groups of individuals to support individual capabilities. The display could provide perceptual and cognitive support. It could be compensatory. For example, a system could identify an individual being colorblind or being an older adult or a user of a different language and then provide the appropriate warning for that person. Tailoring could begin to address or deal with the fundamental principle that warnings should be presented when and where they're needed. Also, tailoring can be used to decide whether to present and what to present. People have different needs, and about 15 years ago, Mike Kalsher and I did another study in which we looked at relevance. We had an electronic sign, and it either gave the person's name who was participating in the experiment, or it just included a regular signal word like caution, or there was, of course, no warning condition. When there was the person's name, more people complied than just the regular caution signal word. An extension of this is to modify a warning based on a person's experience and skill level. An expert may not need a warning, or if a warning is given, it could be abbreviated or more technical. For a novice, the information might be simple, brief, and limited in scope to avoid exceeding attention and memory limitations. In a recently published article in TIE's Theoretical Issues in Ergonomic Science, Tanya Smith-Jackson and I studied preferences of ordering of information and material safety data sheets, MSDSs. And these sheets contain detailed, comprehensive information about chemicals and are usually many pages long and are, for most people, very difficult to understand. We found that different user groups prefer different ordering of the sections, of the MSDS. For example, fire personnel wanted to have certain information at the beginning of theirs, and regular individuals wanted protective equipment for theirs. And so here we were kind of demonstrating that if you did have electronic MSDSs, you might put certain information first, prioritize it depending on their needs. Another extension of this is sensors could potentially pick up complex interference patterns. This is not a very good depiction, but what I meant to show in this is that to have a sensor across a keyboard that would sense the position of the hands. And if the hands are in the proper position, no warning is given. If it's out of position, a warning is given. Okay? And this would enable perhaps retraining of individuals' posture and behavior, which might be otherwise difficult to change. You might even think of a larger sensor system able to register whole body positions and movements. If the person is doing the right thing, no warning is given. But if not, the warning is given until the individual does the proper movement or places themselves in the right posture. And this kind of system might be of some benefit to physical ergonomists intervening to correct or train away improper behaviors that might otherwise be difficult to change because people tend to relapse into their old behavior. Let me offer a short summary of some of the topics I've covered, and before I get to a few final comments. Future warnings will have properties different and better than traditional static warnings. These improvements will include dynamically modified message content, new kinds of displays, sensor systems to detect hazards, and personalization through tailoring to meet the needs of particular users. The goal is to deliver accurate, appropriate warning information in a timely fashion when and where it's needed to prevent injury and damage to property. I believe that technology's involvement with future kinds of effective warnings will be ubiquitous. I show this electronic paper display again because I think something like this might be common all over the place in the future. Of course, sometimes it may be used for warnings, and other times it may be turned off or displayed other things. Implementation difficulties, my last little topic to close out. The promise of future technology-based warning systems is substantial, yet there are a number of potential barriers and difficulties in their implementation. Some of the sophisticated tailoring systems I've described could generate personal security and privacy concerns. An example of this has been suggested with the implementation of the automatic red light photographing that some municipalities have. A picture is taken of vehicles running red lights at intersections, and there have been a few reports where people have received an automatically generated ticket that gives the location of where the violation occurred, and someone has found a relative has been at a place where they shouldn't have been, and find out that it might have been an affair. So there needs to be a balance between maintaining privacy while still promoting personal safety. How much privacy are people willing to give up? Having more information makes better tailoring of warnings, and with that, potentially better security, safety, and reduced injury severity and pain and suffering. These and related issues are complex and are being debated by numerous groups in academia, government, and industry as similarities to the Patriot Act and the loss of privacy due to terrorism concerns. Loss of privacy is probably more acceptable if there's an impending serious hazard and the monitoring is done at work or in a public setting compared to monitoring folks while they're in their home. Another implementation difficulty is intrusiveness and annoyance. We know that this could be the case for auditory warnings. Of course, annoyance can be reduced by better control, resulting in fewer false alarms. Lastly, another impediment is cost, including the hardware and software involved. But I think the cost, as I mentioned earlier, will go down. And so I don't think that that's going to be much of a problem in the future. And in addition, I think the sophistication will go up. Well, as I close out, I hope you enjoyed some of the potential future thoughts of where warnings may go. And also, for Ken, I'd like to thank Mike Kalsher for inviting us, and it was a pleasure being part of the Arnold Small Lecture on Safety.
Okay, I think we have time for a little discussion. If somebody would want to come up and ask a question or make a comment.
I have two questions. In trying to put the two halves of your talk together, a couple of things came to light. The first is I found the list of technological solutions to the warnings problems interesting, particularly with respect to attention, explicitness, and habituation issues. But that still leaves the big three: familiarity, modeling, social influence, and cost of compliance, which all seem to be based on perceived risk. And I don't see a technological solution to that. So I wanted to ask you about that. Second question. Finally, we have a warning standard that's now being slowly extended to owner's manuals, for example, ANSI C535, and coming at the time when there's a proliferation of media. And it sounds to me like the proposal is that, well, we forget the standardization process and blow it up in preference for taking advantage of available media. And I wanted you to talk about that.
Well, maybe Ken has some comments, but you're right as far as the familiarity and cost of compliance. It may be difficult to solve that by technology. I think that, however, the modeling could still be dealt with. We've done a study where we did the modeling on video, so you could potentially be showing people how to perform the correct behavior through some of the displays and systems that I talked about.
Yeah, one of the other things you mentioned was familiarity. And we know that's pervasive in affecting things. But Mike talked about tailoring. And the concept there is to have some measures of individual characteristics that might address some of the concerns that the airlines. So there is some possibility there.
Okay, quite a few comments on the age differences, specifically how children and seniors might understand and comply with some of the warnings we've been discussing.
Well, one of my students who's here, who gave a talk yesterday, was attempting to at least have a beginning type of research on the kinds of statements that might be put onto smoke alarms that would be effective for kids. And designing warnings for kids is very difficult. I do have a chapter with Mike Kalsher in a book that was just released this year, and it's Ergonomics for Children. It's probably in the displays. And we give some of the things that could be done for children. I tended to think that still a lot of the warnings need to be given to caregivers. So that's the kids. Because it's very difficult to be able to design warnings for 5-year-olds, for example. However, kids that are 12 are good. You can communicate some things fairly well and not ignore them. For example, I think the airbag warning, which says 12 and under 12, 12 age, that they're assisted, the parents are assisted, because they can read it themselves. As far as the older adults, Chris Mayhorn and Wendy Rogers and a number of other people have done some research on older adults. Certainly some of the things that you could do with electronically is increasing the size, okay, and putting greater contrast and several things like that.
There's also, as our social psychology colleague would tell us, the invincibility complex that plagues late adolescents and early adult males. And this is something that automobile insurance companies have known about forever. Some problems may not be solvable with warnings.
One comment is if you talk about the information on the internet, there also apparently is a misinformation on the internet, and it seems to me this is something that we ultimately need to be concerned with.
Dave, I know exactly what you're talking about. Chris Mayhorn and I have a paper in press that's going to be dealing with the fact that people can't recognize what's a valid website versus not. And one of the examples in the paper is that we had a website that had the National Ergonomics Association, and then we had another one that was the Human Factors and Ergonomics Society. They thought the National Ergonomics Association was a more valid website than the Human Factors and Ergonomics. They just can't tell. And I don't know if one of the things we suggested is having some background list to look at what's a valid website. And I think it's a difficulty, as you know, that people, at least in my classes, I have to tell them they cannot use internet sources. I mean, at least ones that just have .com and certain things like that. There are things they can get through the internet, but it should be through the library, I think.
You often are told that warnings are to be applied, even though they're not. What's preferable is redesign or reformulation of a product. My question is, do you advocate any kind of methodology for determining if warnings are indeed appropriate? For example, the car example. Is there a point where, is there a method you can advocate that perhaps in the future you would tell an automaker you're going to have to put a lock on the seat back or moving and so forth, or improved seat belts that are attached directly to the seat and just a green strap or something? Do you have some kind of algorithm that you could recommend to help us determine if warnings are appropriate?
I'm not sure I have an algorithm for it, but I'll give you a quick example. Within the last couple of months, we've probably read in the newspaper, some of us, about a problem that Katrina victims were experiencing with the trailers that were made available to them by the federal government, and the formaldehyde in the wood in the trailers that was causing respiratory problems. That's not a problem that's solvable with a warning.
Warning, do not live here.
Yeah, I mean, it's a problem of take it off the market or get the formaldehyde out of the wood. And I think we need to keep that in mind. That one, I don't have an algorithm, but maybe one rule of thumb is, and another example I give them, and I'll make the rule of thumb, is before we got more options about airbags in vehicles, what about the very short woman in the driver's seat who had to be up close to the airbag in order to operate the car? You could tell them what the hazard was, you could tell them what the consequences were, but what are you going to tell them to do about it?
I think they had pedal assistance.
Yeah, and how good an option is that, and so forth. But my point is that sometimes warnings are not a solution because they don't solve it. You can tell somebody what the hazard and consequences, and we see them, we encounter that in some way. And I had a couple of other examples over here, but the point is made. Other than that, I don't know. Yeah. I learned this through working on some legal cases many, many years ago. Nobody knew better. In the 1920s and 30s, there were a lot of three-fingered punch press operators. And nobody knew better than those three-fingered punch press operators that you didn't want your hand under that piston when it stroked. And the reason it was happening is they lost their rhythm as they were feeding things, or somebody walked by and distracted them, and so forth. And a warning wasn't going to change that. The solution to that problem was a procedural guard. Two controls that had to be simultaneously activated, one with each hand, such that your hand couldn't be under the piston when it stroked. So there's another example where guarding and design have to be implemented and not rely on warnings where, for built-in reasons, the probabilities are somewhere between 0 and low. Are we ready for a break?
I think we're ready for a break. First, join me in giving a warm round of applause to our speakers.